conduct electricity. Now, so far we have been talking about good conductors and poor conductors of electricity. So now we are focusing only on the liquids. Is it that all liquids are good conductors, or all of them are poor conductors, or some of them are good and some of them are poor conductors? So let us try to make use of our tester with various liquids. So let us start with distilled water. Distilled water is nothing but pure water. So this water doesn't contain any sort of impurities, no added salts, no other acids, no chemicals, nothing. So it is completely pure. Now what was found was that when we inserted the free ends of our tester, this is our tester. Now you see these two ends, they are not touched. So what is there in between? In between these two ends, we have distilled water. Now what should happen? If distilled water is a good conductor of electricity, then as soon as we dip the free ends into distilled water, the circuit should get completed, because these two ends are connected by distilled water. And if it is good conductor, then current should flow and the bulb should glow. But what is happening? The tester says that the bulb is not glowing. That means the circuit did not get completed, which proves that distilled water is a poor conductor of electricity. Now you might say that sometime back, while you were talking about good and bad conductors, you said that water is a good conductor, but now you are saying that it is bad conductor. Well, right now I am talking about distilled water, that is purest form of water which does not contain anything in it. So pure water is always a poor conductor of electricity. Now let us see what happens when this water contains a little bit of added impurities or added salts. So let us consider the example of tap water, the water which comes out of the taps in your house. So if you take that tap water, that is not pure, that they contain mineral salts and so many other stuffs within them. So now when you connect your tester to the tap water, what do you see? The bulb glows. So this shows that it is a better conductor of electricity, or we can say a good conductor of electricity, because the bulb is glowing in this case. Now in the same tap water, you add a little bit of salt. So you are purposely adding some salt to this water. Now what do you see? You see that again the bulb glows. In fact, now the glow of the bulb is more. In this case the bulb was little dim, but here the bulb glows even more properly. So this shows that salt solution is more conducting to electricity. It is a better conductor of electricity, right? So what do we observe from this? That yes, liquids conduct electricity, but that doesn't mean that all liquids will conduct electricity in a similar way. Some of them will, very easily conduct electricity. Some of them will be poor conductors of electricity, that is, they will conduct electricity only under certain situations. Right? Like here, if you look at the difference between tap water and salt solution, you see that here the bulb, in case of salt solution, the bulb is glowing more bright when compared to the tap water. That's because the tap water doesn't conduct electricity that properly. So it is not conducting a lot of current. Now the more current reaches the bulb, the more glow will be there in the bulb. Now other than water, let us try to look at some other solutions as well. So what did we see? We found that some liquids are good conductors while others are poor conductors of electricity. Now let us take the example of lemon juice. So if you make a solution of lemon juice, take water, add some lemon juice to it. What do you see? You see that the bulb glows, which says that it is again a good conductor of electricity. Now what does lemon juice consist of? Lemon juice consists of citric acid in it. Right? So now why I am telling if it contains an acid or a salt, that I will tell again a little later. Let us just look at the different solutions as of now. Let's take another last solution, that is vinegar. And in vinegar, what do you see? The circuit is completed again, but the bulb doesn't really glow. Why? That's because vinegar is again a poor conductor of electricity. So it doesn't conduct enough current to glow the bulb. So current, it is not that vinegar is an insulator. It also conducts current, but it conducts very less current. So the current is so small that it is not able to heat the filament of the bulb enough to make it glow. Now, instead of the bulb, if you say attach something else like an LED to the vinegar, then maybe it might start glowing, because LED requires less current to glow. LED is nothing but light emitting diodes. They are small diodes and they require very less current to glow. So in this shows that vinegar is a relatively poor conductor of electricity. So based on this, we found that liquids conduct electricity. Yes, they do conduct electricity. Some liquids are good conductors while others are poor conductors of electricity. So here you see all the liquids which we have discussed, they are all shown here. So with distilled water, the bulb did not glow. With vinegar, the bulb did not glow almost, because the current which it could conduct is very less to make the bulb glow. With tap water, the bulb was dim, but with salt solution and the lemon juice, the bulb was glowing quite bright. Right? So what do we conclude? We conclude that mostly solutions of acids, bases and salts, they are generally good conductors of electricity. So here if you see tap water is not pure. It contains some salts, dissolved salts in it. Again, if you look at the salt solution, of course it contains salt in the form of NaCl, sodium chloride. In lemon juice, again you have citric acid, which is an acid. If you talk about vinegar also has an acid, that is acetic acid. Now you might say, but the bulb is not glowing. That's because it is not that vinegar is not conducting any current. It is conducting current, but the amount of current which it is conducting is less. So it is conducting less current. So instead of the bulb, if you put some other device which needs less current to glow, then that device will glow. But when you talk about pure conductor, it is not allowing current to pass through it, because it doesn't contain any acid, base or salt. So distilled water is definitely a poor conductor of electricity. So this way we see that there are many such liquids also which conduct only at certain situations. For example, vinegar is one such example. So if you actually put some heavy device to be glown with the help of vinegar, then it becomes little difficult. But sometimes under certain situations, vinegar can also conduct electricity. So if you look at each of these stuffs which we have spoken about,